Yes, hello. How are you all? My name is Yogesh and we are doing standard 12 statistics. We are doing part 2, chapter number 2, in which we had started the topic binomial distribution in last lecture. This is my second lecture for this binomial probability distribution. I would like to revise what we had done in the first lecture. I told you about the concept of binomial distribution. Binomial distribution is based on an experiment which is known as Bernoulli trials. Now, what this Bernoulli trial says, it says that every experiment has two outcomes. That means only two things happen: either yes, either no. Either you pass, either you fail. Okay, so only two things are there in the result, that is success and failure. If total of probability is 1 and I am dividing it in only two parts, success and failure, so the total of success and failure will be 1. So P plus Q is 1. We had learned the formula how to solve the sum. In each and every sum, you should find this much things. You should find N in the sum, X in the sum, and obviously P and Q in the sum. If you are finding P, then you can get Q automatically because total of P and Q tends to 1. I hope you are getting my point. Okay. We had seen some of the examples also. Last example we have seen was like this: dice is tossed, 5 or more digit is a success. Now in dice there are total 6 digits. Okay, so if I want the digit 5 or more, so there are 2 digits out of 6 which are 5 or more. So 2 by 6, that is 1 by 3 is my success. If 1 by 3 is success, 2 by 3 is a failure. Total there are 6. You want 2 success out of 6 times, that means n is 6 and x is 2. And we had solved with the formula p of x ncx p raised to x q raised to n minus x. You can see my last lecture also if you don't find the thing which I am telling you now. Okay, I am revising the last lecture, so I am in bit speed. Okay, now today we are moving to the questions of the textbook. We are starting with exercise 2.2, sum number 5. An example, I am reading the question first. An example is given to 6 students to solve. The probability of getting correct solution of the problem by any student is 0.6. Okay, so they are telling you that a sum is given to 6 students and students can solve. The probability is 0.6. Students are trying to solve the problem independently. Find the probability of getting correct solution by only 2 out of 6 students. So total there are 6 students. You want 2 students to solve the solution correctly. You can see here total there are 6 students, that means n is 6. You want 2 students to get the correct answer, that means your x is 6. What you want? Correct solution. The probability of correct solution is what? 0.6. That means this 0.6 is what? P. Sir, there is a P given in the question, Q is not given. Is there any printing mistake in question? No, absolutely no. Okay, if you are having P in the question, that means you are having Q, because P plus Q is 1. If you are getting a P, you can put it in the formula and get the result. Okay, so now let us solve this sum. So I am writing the question. It is from the exercise 2.2. Question is number 5. Now what you have in the question? You are having n is equal to 6. You are having x is equal to 2. You are having p is equal to 0.6. See, now I am solving in this question. P plus Q always equal to 1. Now you have P as 0.6, then Q. So 0.6 plus Q is 1. Now your Q is equal to 1 minus 0.6, that is 0.4. So now you have all the four things. You have N, you have X, you have P, and you are having Q. Okay. Now I want to find the solution. So P of X is NCX P raised to X Q raised to N minus X. So it's P raised to X Q raised to N minus X. So now this is P raised to X is 2. So it's P raised to 2. Now what is P raised to 2? It is NCX. So it's 6C P. What is P? It is 0.6. Raised to 2 is what? What is Q? Q is raised to N minus X. So now see how I am going to solve this sum. P raised to X. What is X? X is 2. Q raised to N minus X. Q is 0.4 raised to N minus X. N is 6 minus X. X is 2. Okay. We are doing everything step by step. Huh? So P of 3 will be. Now what is 6C2? Let's solve the 6C2 in the next step. 0.6 raised to 2. 0.4 raised to 6 minus 2. So it's 0.6 raised to 2 and 0.4 raised to 6 minus 2. Okay. Now P of 2 is equal to 6C2. 6C2 is 6 into 5 upon 2. So if you solve 6C2, it's like 30 by 2. So the answer is 15. Okay. So is equal to 15 into 0.6 raised to 2, it's 0.36. And 0.4 raised to 4. So 0.4 into 0.4 into 0.4 into 0.4. It's 0.0256. Now just you have to simply multiply these three things and you are getting the. So my P of 2 will be 15 into 0.36 into 0.025. So it's 0.1382. You can term it as 0.14 or you can write 4 digits 0.1382. It is fine. And both are correct to their calculation. Okay. Now next. So what are the next solutions? So let us start with illustration number 11. There are 3% defective item in a items produced by a factor. So factor is producing some item, and of them 3% are defective. 4 items are selected at random from the item produced. What is the probability that there will be not any defective? As I told you that from any question, first of all you have to read the question carefully, and from any question you have to derive what is n, what is x, what is p, and what is p. Okay. So you can see that 4 items are selected. So your n must be 4. Okay. You have to find the probability that there will not be any defective item. So defective item is p for you. Now this p is 3%. Now 3% means, see, if you want to convert it percentage into probability, percentage is this 3%. You have to divide it by 100. So this 3 by 100 is 0.03. Okay, this 3 by 100 is 0.03. So this is P. Now you got only two things, N and P. Yes, Q you can get it, so I'm not questioning on the Q. But I will question on the X. What is X? Just read the question. What is the probability there will not be any defect? So there should be no defective. If out of 4 you don't want any defective items, that means you want the items to be 0 defective. What do you want? You want item to be 0 defective. There should not be any defect in the item. So item should be what? 0 defect. Okay. So let us solve the question. So this is illustration 11. Now what is given in the illustration 11? Your n is 4, your x is 0, p is 0.03. Now if p is 0.03, you very well know that p plus q is always equal to 1. Now p is 0.03. Or you can say if p plus q is 1, then q is equal to 1 minus p. Okay. So q is equal to 1 minus 0.03. So q is 0.97. So q is 0.90. Now p of x is ncx p raised to x q raised to n minus x. So p of x is ncx. Now what is n? It's 4c0. P is 0.03 raised to 0. Raised to 0. 0.97 raised to 4 minus 0. Now let us solve this. How to solve this? 4c0. Now there is a rule if you remember, NC0 is always 1. So if you get anything as a 0, NC0, then answer is 1. Okay. Then 0.03 raised to 0. If any number, if any number raised to 0, then answer is again 1. So now what left is 0.97 raised to 4. 4 minus 0 is. So what left is this. So it's 0.97 into 0.97 into 0.97 into 0.97. So it's 8853. Okay, if I get the answer in 4 digits, it's 0.88. So the probability of getting no defective item is 0.885. Now let us do the next illustration. Illustration number 12. The probability that a person living in a city is non-vegetarian, 0.2. The probability that a person living in a city is a non-vegetarian is 0.2. Find the probability of at most 2% of 6% randomly selected from a city is a non-vegetarian. So again, the same process, we have to find NXEQ from the question. The probability that a person living in a city is non-vegetarian is 0.2. Find the probability at most 2% out of 6. Out of 6, that means you got your N. Okay, so N is equal to 6. At most 2%. Okay. Now this at most 2 means. What this at most 2 means, you know? See, at most 2 means maximum 2. Maximum 2. So it means 2 or less. Just try to understand it. You don't have to mug up the things. Okay. At most 2, that is maximum 2. What maximum 2 means? It should not be greater than 2. In short. So now if the digit is not greater than 2, 2 or less than 2 will work. Okay, so they have asked you about uh, 2 x's. So your n is equal to 6, p is equal to 0.2, q is equal to now see, if you know that p is 0.2, then q will be 0.8. Okay, x is equal to 0, 1 and 2. See, it is very simple. If I tell you that at most 2 is maximum 2. Maximum 2 means 2 or less. So 2 or less will comprise of 0, 1. So you are having 3 values of x. You got my point? You are having 3 values of x. So what we'll do, we'll find each and every value one by one. We'll find each and value one by one. If I am taking P of 0, I'll solve like this. See, first of all, we are writing the formula. It's NCX P raised to X Q raised to N minus X. Hmm. Now NCX is 6C X. Now this is 6C0. We are finding P of 0. So let's write like this. 6C0. Then P raised to 0.2 raised to X. That is 0.2 raised to 0. Then 0.8 raised to N minus X. That is 6 minus 0. Now how we will solve this question? 6C0 is 1. 0.2 raised to 0 is 1. 0.8 raised to 6. So it is 0.8 raised to 6. So 0.8 into 0.8 into 0.8, 3, 4, 5, and 6. So it's 0.262. In a similar way, I'll find each and every x what I want to find. So I want to find P of 1 now. So this is 6C1 0.2 raised to 1 and 0.8 raised to 6 minus 1. Now P of 1 is 61 is 6. 0.2 raised to 1 is 0.2. Now you have to solve 0.8 raised to 5. So P of 1 6 into 0.2 into, now what is 0.8 raised to 5? It's 0.8, 2, 3, 4, 5. 0.2, 0.32768. 0.32768. So now your answer is 6 into 0.2 into 0.3276. So it's 393216. 0.3932. Then I'll be finding P of 2. So what is P of 2? It's 6C2 6C2 point 2 raised to 2. and point 8 raised to 6 minus 2. Now what is 6c2? You can say it's 6c2. So 6c2 point 2 raised to 2 and point 0.8 raised to 6 minus 2. So this is point 0.2 raised to 2, 6 minus 2 is 4. Now what is 6c2? 6c2 is 6 into 5 30. 30 by 2 it is 15. Point 2 raised to 2. What is point 2 raised to 2? Point 2 into point 2. That is 0.04. Point 0.8 raised to 4. That's point 0.8 into point 0.8 into point 0.8 into point 0.8. That's 0.4096. So this is 15 into 0.04 into 0.4096. So it's 0.24576. 0.2. Now what we want that probability of at most 2%. Probability of at most 2%. This P of 0, P of 1, P of 2. Now this P of 0 is, see we solved everything. P of 0 is 0.2621 plus P of 1 is 0.3932 plus P of 2 is 0.24. Now if you add everything, 0.2621 plus 0.3932 plus 0.2458, you will get 0.901. So your answer to the question, that is a probability of at most 2 out of 6% is 0.901. Okay. So that was for today. We'll continue this chapter in the next lecture. Till then, it is my humble request to you that if you are seeing this lecture, you have to write each and everything what I am repeating. You can pause the lecture and write, but the writing is very important. Okay, this chapter is not so difficult at all, but it might not be easy at all because if you will see the question in the exam, to click that what you have to do is very difficult. Okay, now I am teaching you. You already know that we'll do in this pattern. It will be easy. Then exam sometimes this small question does not click in your mind that you have to solve with this formula, solve with this kind of method. So it can make some difficulty to you. So you have to compulsory write and learn. Okay, in each and every lecture of mine. So thank you. That's all for today. Take care.